Relativity of Space-Time-Symmetry, Congruence to Biocharality. Review by Victor V. Dyakin. One of the persistent problems in biology is associated with the fact that understanding many essential molecular phenomena, such as DNA mutation, amino acid racemization, and protein aging, requires consideration of primary quantum mechanical effects closely associated with the concepts of space, time, symmetry, relativity, and non-equilibrium thermodynamics. Indeed, the entire molecular system of living organisms, including deoxyribonucleic acid, DNA, proteins, and lipids, exists in the dynamic non-equilibrium state, which, by definition, is prone to a variety of spontaneous processes, such as relaxations, mutations, or racemization. The puzzling questions of the origin of life may be resolved only by assuming that physical and biological entities obey nature's universal laws grounded on fundamental attributes of space and time, space-time symmetry, STS, and space-time relativity, STR. If symmetry is about how space and time are related, then symmetry is a measure, a metric, of relativity. In a more general sense, symmetry and asymmetry, characterizing geometric and causal structures, are the metrics of not only space and time, but also metrics of relativity. In the language of formal logic, the integrity of the universe means that every part of nature exists only in relation to the rest of the world. In other words, the integrity thesis is the most generalized form of the relativity principle. The convincing manifestation of the above principles is the growing, not interrupted, chain of evidence that space-time symmetry is crucial in the physical and biological world. The core of all currently circulating mathematical space-time models is symmetry, and, even more specifically, chirality or handedness. Mathematicians can explore the behavior of right-handed and left-handed space-time under specific formal conditions. The results require additional intellectual effort to find their relation to the objective world. Under various conditions, symmetry reveals a fundamental feature, relativity. Chirality, or handedness, as a specific form of symmetry, asymmetry, is a geometrical characteristic of the objects or system of objects studied in physics, elementary particles and galaxy structure, chemistry, biology, and mathematics. Intuitive impression determining whether an object is chiral or not is seemingly straightforward. Chirality, treated as an absolute characteristic, assumed a sharply distinct binary answer of yes or no. However, under more analytical consideration, simplicity has disappeared. An unexpected discovery was that chirality does not have an absolute meaning, and attempts to quantify the degree of chirality meet not trivial complexity. It was found that chirality and closely related characteristic helicity exhibit many different forms of relativity associated with the parameters of motion or energy state. A known example is the helicity of electrons, depending on the relative motion and geometry of the object and frame of reference. Some specific aspects of sensory perception are attributed to the chirality, handedness, human reference frame. Human hands and brain hemispheres, having a high degree of similarity, execute different functions. The dynamic of the chemical reaction also depends on the partner's relative chirality, object versus reference frame. Mathematicians use the dimensionless parameter degree of chirality, formalizable to the interval 0, 1. In quantum chemistry, similarly, chirality and degree of chirality are distinguished between molecular enantiomers. The attempts to reformulate relativity principles from diverse platforms of symmetry are known from the early 1950s to the present. More generalized reformulations of the relativity principle reflecting the relative nature of the symmetry are on the way to being accomplished. The question of why mirror symmetry and asymmetry, chirality or handedness, play such an influential role is a driving force in many advanced studies in physics and biology. The specific aspects of space-time elasticity and spontaneous symmetry breaking in condensed matter phase transitions, cosmology, and biology are dispersed among the specialized literature of multiple subfields, making them not widely known or readily transferred to other branches of biological science. Understanding the commonality of the laws of physics and the laws of life as the form of symmetry removes the veil that mystifies the question of life's origin.